All right, thank you for making it to the last video for this series on chapter 5.6. We already did a proof using the side angle method. And in question 8 here, we're going to be using the angle side method. So just kind of point that out there. All right, so as with all proofs, given statements go on top, proof statements go on bottom. First reason is always given. So point O is the center of the circle. And let's go ahead and write this on a different line just because of the space. Angle N is congruent to angle P. And we already see those are marked there in the figure. Okay, so I'm going to put given for both of those. Okay, and then the proof statement, I'll put that at the bottom. The triangle MNO is congruent to the triangle PQO. Okay, and I can actually already put the reason, right? Because the directions are telling me to use the angle side method. I can go ahead and put that reason in, right? Angle side congruence there. Okay. So what that means is in my proof, I need a statement about a pair of angles, another pair of angles, and then sides. Right? And I already have one statement about angles, right? So this is, let's call this statement number 1, 2, 3, 4, and 5. All right. So we've got, let's see, we're looking for angle side. So we already have our first pair of angles. We need another pair of angles now. And for me, it's not obvious what this is at first. So I might skip it and go look for a pair of sides. Okay. Now, because this is a circle, right, any line that extends from the center, sorry, any segment that extends from the center to the edge would be considered a radius, right? So O to Q is a radius, O to P is a radius, O to M is a radius, O to N is a radius. But the thing is that the radius is the same length no matter where, right? Just think about like the hand of a clock, right? It goes around, okay? It stays the same length, okay? No matter which time it's pointing to. Okay? So we can claim that all 4 of these segments, right, that originate at O and extend to the edge of the circle are the same length. All right, so I can choose any one of these to be my pair of sides. Let's just do like NO and OQ, and we'll say those 2 are congruent. Okay, so NO is congruent to OQ. And my reason, well, I argued because these were all like, each of those segments was a radius of the circle. So I'll probably just put in the reason like the word radius. Okay. All radii, right? That's the plural for radius, are equal lengths. All right, so now I've got one pair of angles, I've got one pair of sides. I need to find another pair of angles. Okay, but now I'm looking at this triangle. Let me turn it this way, and what I see is I see an isosceles triangle, right? 2 sides are congruent, so the 2 angles here are going to be congruent as well. So N and M will be congruent to each other. Sorry. And same thing with this triangle, right? This is an isosceles triangle as well. So angles P and Q are going to be congruent. So really, all 4 of these angles are congruent, right? They all have the same mark. So I already have that N and P are congruent, so the other pair must be Q and M. Okay. So angle Q is congruent to angle M. Okay, so how did I determine that? Well, I used the fact that these were isosceles triangles. So isosceles isosceles triangles have congruent base angles. Okay, so the two base angles are going to be congruent here and going to be congruent there. And look at that, we finished the proof. Okay, so we have our given statement at the top, our proof statement at the bottom. We already knew we were going to use the angle side method. Okay, so we had a pair of angles, that one was given. We found another pair of angles, right, just due to the fact that we ended up finding out these were isosceles triangles. And then we have a pair of sides because each of these sides here were a radius of the circle. So if we highlight it, we have angle, side, angle, side. Okay. Angle, side, angle, side. All right. So both triangles fit that pattern of marks.